Thermodynamics. Today we will start with thermodynamics. So thermodynamics actually means, thermo means heat, thermo is heat, okay, and dynamics is in motion. So thermodynamics means heat in motion, okay, the heat in motion, that is known as thermodynamics. Understood? Now thermodynamics have some terminologies in it. There are some terminologies in thermodynamics. The most important thermodynamics terminology of thermodynamics is system and its surrounding. So first is system, and the other is surrounding. So these are the two main terminologies of thermodynamics. The system means it is defined as the material or quantity of matter, okay, quantity of matter chosen separately from the rest of the universe, enclosed by boundary surface for the study of certain properties such as pressure, temperature, etc. Okay, so we will say that it is defined as system is defined as any material, we can say it means any reaction or any other thing, any material or quantity of matter, okay, quantity of matter, any material or quantity of matter, and which is chosen separately from the rest of the universe, chosen separately from the rest of the universe, and it is enclosed by a boundary surface, enclosed by a boundary surface for the study of the effect of certain properties, for the study of the effects of certain properties like pressure, temperature, etc. Okay, so this is what a system can be defined as. Okay, now surrounding, any other material or body near or at a distance besides the system chosen. That means the surrounding is the region. Suppose I can say this is the region chosen for the system, okay. This is the boundary, and the region surrounding the boundary means the region which is beyond this boundary is known as surrounding. So any other material or body, any other material, we can say any other material or body, any other material or body near or distant, beside the system chosen, besides the system chosen, okay, that is the rest of the universe, that is the rest of the universe. The rest of the universe means which is outside the boundary, rest of the universe is called surrounding. Okay, this is the two main terminologies of thermodynamics chapter. Okay, system and the surrounding. Now, system in thermodynamics, you will find thermodynamics in chemistry as well as in physics. So in chemistry, thermodynamics is system centric. In physics, thermodynamics is surrounding centric. That is why the positive sign, when we say positive something, say like a positive work done, then we will say that the work is done on the system. Okay, then we will say the positive work is done. And when the system is doing some work, okay, the work is done by the system, then I will give a negative sign, because when we do some work, we lose energy. So if I am the system, I am doing some work, then I am losing energy. Okay, so that is why my initial energy and my final energy will be less than my initial energy. And if you divide and subtract that, you will get a negative sign. But on the contrary, if the work is done in physics, it means the surrounding is doing the work, okay, on the system. So initially the system's energy was low. Then as surrounding work is done, and work is done by the surrounding on the system, the energy of the system is increasing. That is why you see the positive sign in case of physics and negative sign in case of chemistry. So this is the basic difference, and there is no much difference there is in thermodynamics of physics and thermodynamics of chemistry. Okay, now after saying that, let us come to the systems. We will be talking about different forms of systems in thermodynamics, which are the first system is homogeneous system, the second system is heterogeneous system. So homogeneous system and heterogeneous system, these are the basic two systems. Apart from this, three main systems are also there: open system, closed system, and isolated system. We will come to each and every system step by step. So first, let us start with the first system, simple systems, which are homogeneous system, and heterogeneous system. These are the simple system, heterogeneous systems. Okay, one is homogeneous system and the other is heterogeneous system. Okay. So when we are talking about homogeneous system, it means a system which is, if it is uniform throughout. Okay, all substances are present, all substance present in it have only one phase. Okay, all substance present are in one phase. All substances present in only one phase. This is homogeneous system. All the substance, if it is gaseous, then all will be gaseous. If one is liquid, then everything will be in liquid. Okay, one liquid, one gas, one solid. That type of system is not homogeneous. So if I am coming to heterogeneous, then this will be just the opposite of homogeneous. We will say that non-uniform throughout. Okay, non-uniform system, that is, all substances has more than one phase. All different substances are in different phase. Different substances are in different phases. Okay, different substances are in different phases, or more than one phase are present. Okay, more than one phase are present. We can also say that more than one phase of substances are present. So this is how we can distinguish between homogeneous system and heterogeneous system. Next, we will come to the three main, these are the basic systems, and we will now go for the main system. The main systems are open system, closed system, and isolated system. Okay, so first is open system. Next is closed system. Okay, and the third is isolated system. So apart from homogeneous and heterogeneous systems, we have an open system, we have a closed system, and we have an isolated system. So what does an open system means? Open system actually means a system which can exchange a system which can change, which can exchange both mass and energy, which can exchange both mass and energy. Okay, a system which can exchange both mass and energy. This is known as homogeneous system. Okay, sorry, open system. And system which can exchange both mass and energy with the surrounding. Okay, with the surrounding. Okay, a system which can exchange both mass and energy with the surrounding is known as an open system. Now, we should know about an example of open system. So The example is, you can say, calcination of limestone is a very important example. Calcination of limestone. Okay. So we all know about calcination process, the process of heating ore, a carbonate ore in absence of air is known as calcination. Okay, mainly carbonate ore. Limestone is, we all know, and the product is formed is the oxide. So this is the one of the, then if you could, if you put a liquid in a beaker, okay, that is also an open system. Now we will come to the closed system. So a system which can exchange only energy with the surrounding and not mass. A system which can exchange only energy with the surrounding. Okay, this is known as a closed system. Means only energy is allowed, like heat is allowed to move from one phase to another, but mass is not allowed. So only energy, it can only, it is allowing only energy to get exchanged between it and surrounding. So this is known as a closed system. Okay, so an example of this is, okay, if you like liquid kept in a silver mirrored double walled Dewar vessel. Okay, liquid kept in um, silver mirrored double walled Dewar vessel. Okay, so this is an example of a closed system. Now, what is an isolated system? A system which neither allows energy or mass to get exchanged with the surrounding. Okay, it does not allow either the mass or the energy to get exchanged. A system which neither allows mass nor energy, it will be nor energy to get exchanged with the surrounding. Okay, this is an isolated system. And the example is any insulated vessel like tea placed in a thermoflask. Okay, tea kept in thermoflask. Okay, so when you keep a hot tea in a thermoflask, you will see that the tea is remained hot for a long duration of time because the system is an isolated system and thermoflask is an insulated, has an insulation. That means it does not allow heat to move out of the system or heat to come in the system. So that is why it is known as an isolated system. It does not allows energy or mass to get exchanged with the surrounding. Okay. These are the five systems, two basic systems, homogeneous system and heterogeneous systems, and three major systems, which are open system, closed system, and isolated system. Apart from this, we will have some properties of a system. Okay, so the terminologies, remember, system and the surrounding, these are the two basic terminologies. And upon that, we have studied about types of systems. Okay, there are two basic systems. One is homogeneous, the other is heterogeneous, and three major systems: open system, closed system, and isolated system. Okay, now we will talk about properties of the systems. Okay, we will talk about the properties of those systems. Okay, properties of the systems. So what are the properties? Means how can you say about what can you say about the properties of the system? Okay, so properties of the system. Number one is intensive property. Okay, the first one is intensive property. Okay, the system is intensive property of the system. Now, whenever we are talking about intensive properties of a system, it means what? It means the property of a system which are dependent on the quantity of matter. The properties which depend on the properties which depends on the quantity of matter, quantity of matter quantity of matter present in it. Sorry, intensive is which is independent. Okay, which is independent. Or the quantity of matter present in it. Present in it. Okay, now how to remember it more easily? So intensive, independent of mass, and extensive will be opposite of this, which means dependent on mass. So intensive, independent of mass, extensive dependent on mass, intensive independent of mass, extensive dependent on mass. Okay, the properties which is independent on the quantity of matter present in is, this is intensive property. Okay, so what are the examples of intensive property? Refractive index. Okay, refractive index. Next is our pressure, temperature, viscosity. Okay, these are the examples of intensive property. Okay, temperature, pressure, viscosity. Okay, so these are the intensive properties. Now, extensive properties. Extensive properties we have just discussed. Extensive properties will be dependent on mass. Intensive independent on mass, extensive dependent on mass. So extensive property these are absolutely dependent on mass. So we will write here that the properties of the system which depends on the quantity of matter. Okay, the properties of the system which depends on the quantity of matter. Okay, do you have any question?
No, sir.
Okay, contained in it. So the examples of extensive properties will be mass, volume,
Density,
yes, density, then heat capacity, etc. Okay, these are all extensive properties. Okay, now we will talk about some of the thermodynamic processes, some of the processes involved in thermodynamics. So thermodynamic processes. Okay, the first thermodynamic process is isothermal process. Iso means same, thermal means temperature. So if you see the process is carried out at a constant temperature, when a process or a reaction is carried out at a constant temperature, it is known as an isothermal process or isothermal reaction. When a process is carried out at a constant temperature, when a process is carried out at a constant temperature, when a process is carried out at a constant temperature. Okay, when a process is carried out at a constant temperature, then you will say that the process is known as isothermal process. Okay, so and in these cases, two of the intrinsic system energies like internal energy and change in temperature is zero. We can say that here the change in temperature is zero. But with this change in temperature, if the change in temperature is zero, the internal energy change, okay, the internal energy change, this is a form of energy that either is designated with del E or sometimes in some books is also designated with del U. It is also zero. Internal energy change if in an isothermal process is also zero. Okay, internal energy change in an isothermal process is zero. Okay, understood? Internal energy change for an isolated process, for an isothermal process is zero. Okay, now let us go to the second form, okay, which is known as isobaric process. Isobaric process. Okay, bar means bar is a unit of pressure. So when a process is carried out at a constant pressure, when a process is carried out at a constant pressure, then we will say that the process will be isobaric process. Process carried out at a constant pressure. Process carried out at a constant pressure. So del P change in pressure will be zero because pressure is constant. So this actually, when we are talking about isothermal process, it was previously discussed in class 10th of ICSC sometimes as Boyle's law. So in Boyle's law, we see that P1V1 equals to P2V2. Okay, that means that P and V, if we multiply pressure and volume, it will be a constant. Okay, and why it is constant? Because, it is constant because the temperature is also constant. So Boyle's law has a main thing in it inside. When you are studying Boyle's law, you will say that the law is followed when the temperature is kept constant. If the temperature changes, then it is not a Boyle's law. Now, when pressure is kept constant, that law is known as Charles' law. Okay, in Charles' law, we have studied that V1 by T1 equals to V2 by T2. It means volume is directly proportional to temperature. Boyle's law, pressure is inversely proportional to volume at a constant temperature. In Charles' law, volume is directly proportional to temperature at a constant pressure. Okay, this is known as isobaric process. Now, the third one is isochoric process. The third one is isochoric process. This process, choric means volume, process carried out at a constant volume. Process carried out at a constant volume. Okay, so here the law which is not discussed in our class 10th syllabus, which is known as Amenton's law, which signifies that pressure is directly proportional to temperature if the volume is kept constant. The pressure is directly proportional to temperature if the volume is kept constant. This is known as Amenton's law. This is what in class 10th, in ICSC, this part has been skipped or the thing is not added. Okay, and it was totally been said in means all the three things are combined together in gas law. P1 V1 by T1 equals to P2 V2 by T2. Okay, where there is nothing actually constant. Okay, but pressure constant is there, temperature constant is there, and along with that, Amenton's law also tells us about this volume constant. That means del V is also zero in this case. Okay, now fourth one is adiabatic process. Most important thing, adiabatic process. Okay, So the fourth process is adiabatic process. In this process, we will say that no heat exchange occurs between the system and the surrounding. No heat exchange occurs. No heat exchange occurs between the system and the surrounding. Okay. No heat exchange occurs between the system and the surrounding. Also, it should be added, no heat exchange and no mass exchange takes place between the or occurs between the system and the surrounding. Neither heat nor mass. So the adiabatic process is a type of closed, isolated process. Okay, no heat exchange, no energy exchange, no mass exchange is taking place between the system and the surrounding. So this adiabatic process actually refers to as isolated process. Understood? Adiabatic process are
Sir,
yes.
how is adiabatic process different from isothermal process?
In isothermal process, you see the temperature is kept constant. So if how can you keep the temperature fixed? If you have a steady flow of heat coming inside and the same amount of heat is going outside. The heat is coming inside and the heat is going outside. Heat is coming inside and the heat is going outside. So steady flow of heat or steady flow of heat energy is going through the system. Okay, it is a closed system. Isothermal process refers to a closed system where energy in the form of heat can move into the system and the same amount of heat will move out of the system at the same time. The amount of heat is coming in is equal to the amount of heat going out of the system. That is why the temperature, the overall temperature of the system is kept constant. Okay. Any doubt? Did you understand?
Sir,
Or should I explain it once more?
না বুঝেছি।
Okay, okay. Now, so this is no heat exchange occurs between the system and the surrounding. It is a isolated system. Isothermal process was a closed system, and this is an isolated system. So here, what we will see that Q equals to 0. Q equals to 0. That means no heat exchange is taking place. So it is entrapped inside the system, and which actually increases the temperature. In adiabatic process, we will see an increase in temperature. That means del T is not equals to 0. There del T was equals to 0. Here del T is not equals to 0. So as del T is not equals to 0, sometimes we can say in some cases, we will consider that del E is also 0 for adiabatic process, but it is actually not so. As Q equals to 0, del H will be 0. When we will going to study about the enthalpy of the process, the entropy of the process, and the internal energy of a process or a system, okay, or some entity or any substance, every substance has an internal energy, okay, and every process has a enthalpy of a reaction, enthalpy of everything is there. So accordingly, we will discuss where each thing actually stays. Okay, this type of processes will again be understood in those segments. Now let us come to the fifth one.
স্যার এইটা আমি বুঝলাম না, মানে নো হিট এক্সচেঞ্জ বলা আছে, তাহলে ডেল্টি ইজন্ট ইকুয়াল টু জিরো কেন হচ্ছে?
Because in an adiabatic process, the exchange of heat is not taking place. কোনো heat exchange হচ্ছে না between the system and the surrounding. No heat exchange. So heat is getting entrapped. The amount of heat present inside the system is there only. Okay, and if you have an energy confined with a heat system and the heat system is not moving outside, so it will tend to increase the temperature of that system. That is why del T is not equal to 0. So initial temperature and the final temperature will be different, and del T will be positive in nature. Okay, there will be a positive value of delta T. Understood? Delta T
স্যার ক্যান ইউ রিপিট
হ্যাঁ অবশ্যই
আরেকবার?
অবশ্যই বলে দিচ্ছি। যখন আমার হিটটা এনট্র্যাপড থাকছে কোন একটা সিস্টেমে, বেরোতে পারছে না, তো সো হিট বেরোতে পারছে,
হ্যাঁ,
তার মানে কি হচ্ছে, হিটটা সেখানে জমাট বাঁধছে। তো হিট যতটা বাড়বে তত টেম্পারেচারও আস্তে 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 বাড়তে থাকছে। যেরকম একটা ঘরের যদি দরজা বন্ধ করে রাখি তো কি হবে, কিছুক্ষণ পরে ঘরটাতে গরম লাগতে শুরু করে দেবে আমাদের। ঠিক আছে, দরজা জানলা দের ইজ নো মানে হোল নেই কোনো জায়গায়, কোনো এয়ার ভেন্টিলেশন নেই, কিচ্ছু নেই, তো ঘরটা গরম লাগতে শুরু করে দেবে, কারণ এটা ক্লোজ সিস্টেম হয়ে গেছে। ওই যে হিট যেটা আছে সেটা বেরোতে পারছে না, সারাউন্ডিং এ যেতে পারছে না, তাই জন্য ভেতর থেকে গরম হতে থাকছে ঘরটা। বোঝা গেল? তো এই জিনিসটা ভেতর
হ্যাঁ হ্যাঁ
টেম্পারেচারটা বাড়িয়ে দিচ্ছে। সো del T is not equals to 0 and it is turning to be positive in case of adiabatic process. ওকে, বোঝা গেল?
হ্যাঁ স্যার।
Okay. Next is our cyclic process. Next is our cyclic process. Cyclic process মানে, this is the cyclic process. Okay, so এখান থেকে শুরু হলো, it starts from the position and it ends in the same position. So this, it is making a whole 360 degree, and we all know that if when we wake up from a bed and if I go back to sleep in the same bed, then total displacement is 0, and so work done will also be 0. Okay, that means we haven't done any work in our day. We do not do any work in our day. We we all have work done equals to 0, because force times displacement, there is no displacement, so there will be no work done. But in this case, the process, the initial state of the system is regained after a series of operation. Here it means the initial cyclic process means a process in which the initial state of the system, is regained. Initial state of the regained after a series of operations. After a series of operations. Okay, this is known as a cyclic process. And in this process, we will see that del E or del U, anything according to each book. Okay, internal energy change is 0, and also enthalpy change is 0. Del H means enthalpy change. Enthalpy change is also 0. So internal energy change is 0 and enthalpy change is also 0 in this case. We'll learn about this internal energy and enthalpy in our upcoming classes, but here we are focusing on this segment first. The sixth one is isentropic process. Isentropic process. So here, what do you mean by isentropic? It means the process in which there is no net change in entropy. No net change in entropy. Okay, means del S is 0. There is no net change in entropy, which means del S is 0. So in reactions where there is a certain amount of gaseous reactant and one amount of gaseous product has been formed, those type of reactions are actually known as isentropic process. Okay. Apart from this, we all know that there are two basic processes, which is known as a reversible process. Okay. Apart from this major processes, one is reversible process and the other is irreversible process. Okay. A reversible process